Okay, we are ready. Yep. So now let us proceed to the next subsection. Yeah, we are already now in chapter 5. All right. Me? Me? Oh. Where were we? Hey, where were we last week? Where? Here? Are we here? No? Here? I think we. Where were we? Here? Or here? Is it here? Here? This one? Before or after? After. Here. 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 Normal distribution? Already here? And here? Or here? This one? Huh? Before that? Or after that? This one. Okay. Okay. So, um, so what have, what are our comment about the figures? What are our comment? There are two parameters, mu and sigma. All right. The first parameter, mu, determines what? Determines what? What? Yeah, very good. Determines the location. And the second parameter determines the shape. Right. The shape of the figure of the distribution curve. Location. So this is mu. There, this is the central location, and this is the central location, and this central location is 0, which is the location of mu, and this is also another. This is another central location of another normal distribution, and the central location is 1.5. We see that the two figures have the same shape, but different central location. Understand? Okay? They have the same sigma, but different mu. But here, they have the same mu, but different sigma. The one with, what happened? Yeah, the one with the sharper, with a sharper head, you know, the one with a sharper head has smaller sigma, and the one with bigger sigma has, you know, more flat curve. All right. Hey, it is 1.4. What is this? What is this? 0.45. So this is very sharp. Okay. We just, you know, a little you know, the upper right figure is a little bit squeezed. You know, squeezed. So you cannot tell the sharpness. If you you know, in fact, it should be longer. The figure should be longer. All right, and so that it is sharper than you saw. You know, than the upper right figure. Then you know, it should be sharper than the upper right figure. Okay, so what is our comment? when sigma equals 0.3, data value are more clustered than that of the data value with the sigma 1 here, okay? Smaller values of sigma implies smaller variation of the distribution. Larger sigma square corresponded to larger variation of the distribution, all right? Okay, and here, please put it yourself, put it on your lecture note yourself, that mu is the central location, okay, and mu determines the location of the curve, the placement of the curve, all right? Okay, mu determines the location of the distribution curve. Okay, that's what we learned last week, all right? That's what we learned last week, okay? And here is the normal distribution. Okay. Raise your hand if you have downloaded the Excel file, and try different combinations of mu and sigma. Raise your hand if you have done it. Raise your hand. Then should I upload the lecture note or other material again? You don't. It seems you don't need it. Okay. Okay. Specifically, look at the slide. Specifically, when mu is 0 and sigma equals 1, that is, x is distributed as n parentheses 0 and 1 square, then x is said to have the standard normal distribution. Hey, look at this word, standard. 0, 1. The first parameter is 0, second parameter 1. Then x is said to have the standard normal distribution, all right? Okay, here now, and if x has the standard, if x has a normal distribution, and then we use the notation x, hey, tilde, and parentheses mu sigma square, okay? And when mu is 1, then when mu is 0, sigma is 1, then x is said to have the standard normal distribution. And n here is short for normal, okay? So for the plot in the previous slide, we see that mu determines the location of the normal distribution curve, whereas sigma determines the shape of the normal distribution curve, okay? All right, so let me wipe off the Chinese character. N for short. All right, standard normal. Here, standard normal. Yep. And what happened to the other student? What happened? They are not here because I use the Microsoft team so that they can learn this online. So they stay home. Roll call time. And I will double the roll call. Yep. Roll call time. Get ready. Yep, here. Here, you have only 5 to 6 seconds. One, two, three, 4, 5. Raise your hand if you are not finished. Okay. Raise your hand if you are not finished. Raise your hand. Okay. Everybody finished. Okay. Second time. Second time. Because I said I will double the attendance. One, two, three, 4, 5, 6. Okay. That's it. So we are already double. Raise your hand if you're not finished. What is your name? What? Later, I will do it manually for you. Please come up when at 12. Okay? Only one can, you know, can make up. Very good. I'm in a very good mood. 蛮爽的。So good. You know, my submission of research article was accepted by a international journal, a very prestigious journal, very good journal. All right. So that's what I'm happy, and also my stock price rise. So I hope you give me some good feedback. Will you comment on the teaching survey that the teacher is a harsh freak? Huh? Harsh freak. You know harsh freak? Or sick? The professor is sick. Will you leave the comment? I don't think so. You will leave the comment that the teacher, you know, is so resourceful, helpful, right? Will you? And we will meet next semester, right? Understand? Okay. And I let you answer the exam question online. Okay. So don't comment that I'm a harsh freak. All right? 变态施压魔王。All right? Okay. Now, note that the area, hey, this is the shaded area. The area in a red shade. Okay. So suppose that the total area under the normal curve, okay, from far left on the real line, from far left to the far right, the total area under the curve is 1. All right? Whatever the shape, it is always symmetric and bell-shaped. All right? And whatever the shape, sharper or flatter, you know, the area is always 1. And what about the area left to the parameter mu? What is the area left to the parameter mu? What is the area left to it? Just 1/2 because it is symmetric. So here the mu split the distribution into 2 equal half, right? Understand? And now, so it is easy. Hey, this total area is 1, and it is easy that the half of the area is 1/2. But what about the area? Uh, what about the area left or right to any point? Here. So, but what is the area left to 1.3 here? What is the area left to 1.3? And what is the area right to 1.75? Hey, this is the standard normal, standard normal, okay? So please go back to the appendix for the normal table. For the normal table, what is? Please go to and now you will see the table as this here. Please go to the table here. Yeah, here. This is your table. This is your table, and the table is the table in your textbook are very user friendly, and many other textbooks provide only 1 page, but your textbook provide 2 pages. So that's why I said the textbook is very user friendly. Okay, so let us look for 1.3. Hey, let us look for the critical point 1.3. Hey, you see this? The right figure, the right table, look for 1.3, right? And the point, in fact, 2 decimal places, 1 decimal place, 1.3, and 2 decimal place 1.30. All right, so 1.30. So what is the number? What is the value here? What is the area here? This is the area left to 1.3 here. So what is it? 0.9032. You see this? So let us go back to the slide. Is it 0.9032 here? Hey, what happened? Hey? 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 Yep, here. Hey? Oh, no, I didn't write it. So what is it? What is it? Where is my pen? Where is my pen? Hey. Hey. Where is my pen? I have 2 pens. Yep. So the area is 0.9032. And what about the area right to 1.75? Okay. unfortunately, the table doesn't provide the tables do not provide the area right to some point, but left to some point. Okay, so but don't worry. But don't worry. Please look for 1.7. The row here, the first column here. Look for the row with cell 1.7. Here it is here. It is here. 1.7, and this column is for 0, 1, 2, 3, 4, 5. So here 1.5, it is 1, 2, 0, 1, 2, 3, 4, 5. Yep, here. Yeah, so it is 9599. 0.9599. 0.9599. Okay. This one. 0.9599. Me? No, this one. Yeah, this one. Let me zoom in. So this 0.9599, 170, 171, 172, and 175. So here the area is the area here is, what is it? 9.9599. So what is the area? The area is 1 minus the area on the left. Okay? The right tail area, the area on the right tail is 1 minus the area on the left. So it is 1 minus 0.9599. Okay? So it is equal to 1 minus 0.9599. So it is 0.4101. Okay? Oh, no. 0. 0.0 and 0.401. Okay? And you see this? Got it? You got it? And it is available. This area is available from the table. Okay? And this area is also from the table. So if you want the area on the right, then you have to do some simple. You need a simple calculation. 1 minus the area left to it. Okay? Understand? So, what is the big deal? What is the big deal about normal distribution? Hey, if there is no normal distribution, can I use your textbook? Then our textbook will be less than 1/2 of the volume. There will be less than 1/2 volume left. You know, it is very important. Without this, we can do very little things. Okay? So that is why we have to learn normal distribution, and that is why the portrait of the German mathematician Gauss is printed on the Deutschmark, the Deutschmark, the German currency, paper money, you know. So what is the then we can make some do some application here, all right? Hmm? What time is it? Yeah, we still have time. I have to yep, here. I need the I need the lecture note of another class. Yep, this one. Download. Yep. And open the file. Hey, what happened? Yep. This one. Where is it? Not this one. Oh, yep. This one. This one here. This one here. Yep. Whoa. Yep. From 30 to 38. From 30 to 38. Okay. 30 to 38. Yep. Hmm? 30 to 38. I think it's this one. Yep. 30 to 38. 30 to 38. This one. Yep, here. $30 to $38 to $3, $4, $5, $6, and $7, and $8. Yep. Yep. So so please go to page 320. There is a very important theorem, and the theorem is not exclusively stated in your textbook, but it is exclusively the theorem exclusively stated in my slide. So please keep this in your slide. Okay. Here is my question. My question is how to transform a non-standard normal distribution into a standard normal distribution. Okay? Hey, this is the general or regular normal distribution, but you know, uh, so what is the table? What is the table? You know, the table you just saw works only for standard normal distribution. Only. It works only for standard normal distribution, okay? But what if the normal distribution we encounter is not standard normal? If it is not standard normal, then we cannot use the table in your appendix. All right? Okay. The answer lies in the following theorem. Okay, don't worry. We can transform any general, any regular, any normal distribution of any shape, any location. We can transform it into the standard normal distribution. And note that here, suppose X is the standard normal with the first parameter mu and a second parameter sigma square, okay? Then let us define a new random variable, x minus mu, and then divided by the standard deviation, sigma. Okay? Hey, this is a x is a random variable. It is a standard. It is all still a random variable after minus mu. Hey, this new thing is also a random variable because the x here is a random variable. So this is a random variable, okay? And when you divide it by the constant, sigma, the whole thing is also a random variable. And it is a new random variable, and let us denote it by z. So z is the new random variable. Then what is the big deal about the transform z? What is the big deal? The big deal of z is that it has the standard normal distribution. So let us denote it by the expression, hey, z equal x minus mu divided by sigma is distributed as a standard normal distribution. So whatever the value of mu and whatever the value of sigma, don't worry. If you minus mu, if x minus mu divided by sigma, then it becomes a standard normal distribution. Then with this, we can use the standard normal table in your appendix, in the appendix of your textbook. All right? 10-minute break. Hey, will you comment on the teaching survey that the teacher is a harsh freak? No, then what should you comment? Yeah, kind teacher. Okay? Too kind. Very kind. Awfully kind, okay? Hello. Yep. Okay. Now, with the theorem, we can do some applications here. Example 6.6. Okay, and an adult has on average 5.2 liters of blood. Okay, assume that the distribution of the volume of the amount of adult's blood is the normal distribution with a standard deviation 0.3. Okay, so the whole paragraph, okay, means that X is distributed as a normal distribution with the first parameter. Hey, you have to find the two parameters value yourself in the exam. Okay, average means mean. Okay, mean value. And what is the Greek letter? Sounds like mean the most. What is the Greek letter? Mu. Mu and mean, you know, sounds very similar, right? Right? So mean, average means mean. Okay. So and it sounds very close, very similar to the Greek letter mu. So 5.2 is the value of mu here, mu, and it says with a standard deviation sigma equals 0.3. So it is 0.36 square. Okay. Find the probability that the percentage of the adult who have less than 5.4 liters of blood in their system, in their, the system inside their body. Okay. The desired percentage. Hey, you want us to calculate the percentage. Hey, the percentage is the probability that X is smaller than 5.4, where X is the amount of a certain adult's blood selected by random, okay, in liters. Okay, so hey, in statistics and probability, when you see percentage, hey, what is the thing that comes first to your mind when you see percentage? The first thing that comes into your mind should be probability. Understand? Percentage is equivalent to probability, and vice versa. Probability is equivalent to percentage. So that's for true in statistics and probability. So, hey, what is the first letter of a percentage? First letter, P. And what is the first letter of probability? Also P, right? So, the idea of percentage and probability, can be used, okay, can be replaced interchangeably. They are the two ideas are equivalent. They can be used interchangeably, right? Sometimes you see probability, then you can think of this probability as the percentage. And when you see percentage, the first thing that comes into your mind should be probability. You can use it interchangeably. They are equivalent idea. Okay. So when it wants you to calculate the percentage, then it means that it wants you to calculate the probability. And the probability is the area, okay, is the area under the curve, okay, over a certain interval. All right. So the whole paragraph means that, hey, X has the normal distribution with 5.2 mu as mu and a 0.3 square as a sigma square. All right. So let us go to the second page. and the calculation is minimal. And in fact, there is no calculation. Only looking for table values. Okay, so this is the desired probability. This is the desired percentage. This is the probability, okay? Originally, it is the probability, but I said probability is equivalent to percentage, okay? So it is a 5 point, it is the probability that x less than 5.4. So please go back to the appendix and look for 5.4. You see you see anything? You see any value 5 point something? I don't think so. The maximum and minimum is 3.5 and minus 3.5, right? Why? Because the table is only for the normal distribution, the standard normal distribution. But is this the standard normal distribution? Is X has the standard normal distribution? No. So we need some transformation before we look for the table. We have to transform it into what? The standard normal distribution. We have to transform it into the standard normal distribution. Okay? Okay. So how to transform it? Minus mu and divided by sigma square. Hey, at the first line of the equation, left is equal to right because they both minus 5.2. Minus 5.2. The probability remains unchanged. All right? It remains unchanged. And it still remains unchanged if they are both divided by 0.3. 0.3, 0.3. And the probability still remains unchanged. All right? Okay? So by the theorem in the previous slide, so what is this? Hey, what is this? What is the distribution of the transform? This is transform variable. This is the z in the theorem. Z has the standard normal distribution in the previous slide. By the theorem in the previous slide, okay? So Z has the standard normal distribution by the theorem, okay? So let us replace the expression by n parentheses 0 and 1, all right? So, and smaller than, hey, what is the value of the fraction? 0.767. Okay, but it is rounded to the second decimal place. Okay, in Chinese, it is, hey, don't comment on the teaching survey that I use Chinese all the time. I use Chinese only, less than 1%. Okay, and then I will wipe it off later. Okay, because I don't want my salary get cut. Okay, so now, okay, so let us go to the table and look for the leftmost column with the cell 0.6. Hey, please go to the table. Go to the table. Please go to the table here. The table is here. What is where is the value? 0.6. Where is it? 0.6 here. Hey, here. 0.6 and 7. Here, the leftmost column with the cell 0.6 and go to the right. Go to the right. This is, hey, this value is for 0.67. So what is the probability? The area is 7794. So the answer is 7794. Okay? 7794 is, hey, what happened? Eh? 那是什么情形? Oh, 7486. 7486, okay? Here. 7486. All right? Let me mark it with a red pen. Mark it. Yep, here. Yeah, this one. Yep. Zoom in. You see this? 0.67. The area left to 0.67 is 0.7486. Okay? Understand? So that's the area left to 0. Hey, probability. Ai, này anh ấy là. Yep. The probability that Z or equivalently the standard normal distribution smaller than 0.7 is 0.74 and 86. Okay? Okay? Yep, here. Right, you have to turn sideways to look at the number. Okay? Turn, turn 90 degree to the right. All right? Don't complain. Or you can wipe it off on the PowerPoint and write your own. All right? If you prefer your handwriting. Okay? So the area left to 0.67. So what is the percentage? So what is the percentage? The percentage is 74.86%. Okay, that's the answer. All right? So the percentage of the adult who have blood less than 5.4 liter is 74.86. The adult having blood less than 5.4 liter Is there a typo here? Is there a typo in this sentence? Is there a typo? Liter, right? Typo is the liter, but I don't think so. You feel that it is a typo, but I don't think so because it is used in a British area, right? It's used by a British, all right, country. Yep. Okay. Yep. Next application. Hey, here we saw the standardization of a normal distribution. The standardization of x is done by minus mu divided by sigma. Okay, and the standardization of x transform x into the standard normal distribution. Okay. Okay. Hey, why do I use the, not a? Why do I use the rather than a? Because there is only one. There's only one standard normal distribution in statistics. No second one. So I use the here. That's what it is not. It is illegal to use a. Understand? All right. Hey, there was a spy standing outside, listening to my teaching to see if I use English or Chinese. All right. And will you comment on the teaching survey that the teacher's English is so poor? So how would you say? Fluent. Okay, okay, above average. You know. So second, the next application, and the next application is described in the example 6-9. Hey, police academy qualification. All right. Hey, it's on page 325. Hey, to qualify for a police academy, a candidate must score. Hey, I need ACE here. ACE. Candidates must score in the top 10, top 10% on a general ability test. Okay, assume that the test score are normally distributed with mean score mu 200 and the standard deviation sigma 20, and find the lowest possible score to qualify the academy test, qualification test. Okay, hey, in Chinese it is called 最低录取分数. Okay, and I have to wipe it off. I don't want it to create. I don't want it to leave any evidence. Yep, here, wipe it off. All right, and also this, wipe it off. No Chinese. You know, early Chinese character are found in the were found in the oracle, turtle shell, 龟壳啊. Oracle, Chinese character, oracle, 甲骨文, turtle shell, right? And they are those character on the turtle shell are the symbol of dialogue between witch and the ghost. You know, 巫师跟鬼神对话的符号。And then later it become Chinese character. All right? So do you think Chinese language logical? I don't think so. Not logical, because it is used to communicate with ghost. So will you be logical communicating with ghost? No. Okay, so you'd better learn English. That is why we use English in the class. Understand? Will you comment on the teaching survey that I criticize on Chinese language? No. You just said my English is okay, above average. Don't comment on my criticism on the Chinese language. Okay? Nevertheless, it's illogical. 没有逻辑。Okay, and and also the people using Chinese language are also illogical. All right? So what is the find the lowest possible score to qualify? Okay, so suppose that, hey, this is the lowest possible, the lower bound for qualified candidate, the lower bound for the score of the qualified candidate. Hey, this is the lowest score. You must score more than X0 to qualify. Okay, candidate must score more than X0 to qualify. So let me explain the meaning of X0. Hey, what is it? The candidate must score more than X0 to qualify. Okay? So that is the lowest possible score to qualify. Okay? And now, if you go to the table, hey, if you go to the table, hey, please go to the table in the appendix. Go to the table in the appendix. Hey, excuse me. Hey, go to the table in the appendix. What is the maximal critical value here? 3.5. 3 point something. And the smallest, minus 3 point something. All right? Thank you. Yep. Can you find value with 200 something? No. So standardization is now necessary. Understand? Necessary. So we have to do the standardization. So how to standardize a normal distribution? Hey, it's always minus the value of mean, and then divided by the value of sigma. Hey, divided by the value of sigma, not sigma square. All right? And so is the term on the right. All right? Okay, so and about the theorem in the previous slide, the thing here, the standardized thing here, the standardized X here has the standard normal distribution. Understand? So it is 0 normal parentheses 0 comma 1. Okay? And what is this? Hey, it is available from the table. found from the table, available from the table. It is to be found in the table. Okay? The thing is to be found in the table. So why is it 1.28? Why is it 1.28? Hey, go to the table to see why. Go to the table. Yep, here. See this? Please go to the table. Hey, hey, look up here. Look up. This is the standard normal distribution, right? The standard normal distribution, right? Now we are given. Hey, this is the given condition. What is it? Only 10%. So probability is the percentage. Understand? And we have to look for the x0 here, but no, z0 here, and it is still unknown, such that the area left to z0 is 0.9. We have to look for the cell value 0.9. Hey, the cell value with 0.9. Hey, unfortunately, there is no value exactly the same as 0.5. We can only for the closest one. Okay? Hey, please translate my English into Chinese. Unfortunately, there is no cell value equal to 0.9 exactly. No. Translate my English into Chinese. One by one. What did I just say? You forgot one word. Unfortunately. 很不幸的. Okay? Okay. Unfortunately, there is no cell value exactly equal to 0.9. So we can only look for the closest one. Hey, so what is the closest one? Where is it? Oh, I got it here. The closest one is this one. This one. This one. And then let me zoom in. This one. Yep. Zoom in further. Yep. Hey, this one. This is the cell value. Okay? The cell, this we call this a cell value. Cells means you know, a value, a place that store value. Hey, this is the cell value 0.8997. Okay, that is closest to 0.9. Understand? Is it better? No. A little more far away from far away from, than a 0.9. Is this better? Is this one better? No. So this one is the closest. cell value, the cell value closes to 0.9. Okay? Yep. Here, cell value closest cell value closest to 0.9. Okay, so we pick up this one. So so what is the critical value? This is the cell value, and this is the critical value. So what is the critical value? 1.28. The corresponding critical value is 1.28. All right. So go back to the example here. So here is how 1.28 is found. So that is why, hey, 1.28. Because so here we found the cell value closest the area, the cell value closest to 0.9 is 1. What? 28. Okay? Okay. And 1.28 is to be found in the table. So what is the difference between this example and the previous example? Raise your hand for extra bonus. Raise your hand for extra bonus. What is the difference between this example and the previous one? The two examples do opposite same things. Okay? Reverse, opposite things. In this example, we are given the area, and we are required to find the critical value. Understand? But in the previous example, we were given the critical value, and we are required to find the area. Okay? So what is the difference between the two examples? Sophia? Huh? No? You don't understand? Right? The lady before Sophia? No? Are you local student? Or international? Where are you from? Oh, Indonesia. So what is the difference between this example and a previous example? You tell me. But please. I'm not infected. You were given the critical value, and you were required to find the area. Yep. You were the second example. You were given the area, and you were required to to find the critical value. So we do opposite things in the two examples. Okay? So you were asked to find the location or the critical value by area you were given. By the area you were given. And conversely, here, you were given the location. You were given the location. You were given the critical value, and you are required to find the cell value or the area. Left or right to the location, to the critical value. Understand? And that's the difference. You have to identify the difference in the final exam. Keep that in your notebook. All right. Yeah. Here. Please allow me to use the green color pen. You will be required to identify the difference between the two examples in the final exam. Okay? And our next example, the next example is my example, not the example in your textbook. So this example has no number because it is my example. Okay? When you see an example without any number, then it is mine. Okay? So suppose that X has a normal distribution with mu 100 and sigma 20. So what is the probability that X lies between 80 and 120? Okay. If you go to the table, you see nothing with 80 something or 100 something. Okay? So you have to standardize X. Okay? You have to standardize. So how to standardize? The standardize is done by minus mu, which is 100 here, and divided by 20, which is sigma here. Understand? Okay. So there are three terms to standardize. Three things to standardize: the left one, the middle one, and the right one. All of them. Okay? All standardized. Okay. So what is this? What is this? It is minus 1. And what is this? It is positive 1. What is the middle one? It is the standardized. So it is the standard normal by the theorem. Understand? Okay. So now the area is available from the table. So we are to find the area. We have to find the area between minus 1 and 1. Hey, not 80 and 120 anymore. So the value, the area is now available from the table, because in your table there is minus 1 something and 1 something. Understand? Okay. So please go to the table with the left. Please go to the table, the leftmost column with the cell value 1 point something, 1.00, 1.00. Hey, if now, hey, the table does not provide the area between any interval. It provides the area left to 1 and left to minus 1. But it does not provide the area between minus 1 and 1. Understand? So what can we do? We can first look for the area, write it to 1, that is from far left to 1. Okay? From far left to 1. And minus the area from far left to minus 1. So the difference between the two area is the area between the interval, in the interval, okay, minus 1 to 1. Okay? Understand? So what is it? If you go to the table, the area left to 1 is 0.8413. And the area left to minus 1 is 0.1587. So the difference is 0.6826, which is the area between minus 1 and 1. So that is how interval area is obtained. Okay? Yep. What? No, it is, oh. If you insist. Yeah, good. But I'm not giving you the extra bonus. All right? Yeah, in some textbook, it is displayed with a square, but in some textbook, it is not. Okay? So, I don't know. It's the convention of different, yeah. I will use sigma square in the final exam. Okay? If you see square, then it is a sigma square. If you don't see square, then it is a sigma only. Okay? So the area is 68.26. Hey, does it look familiar to you? What is this? This is the number in the empirical rule. Hey, the percentage of data that lies between one standard deviation above the mean is 60.26%. Understand? This is how the empirical rule is developed. Right? Okay, let me wipe this off and replace with English. I have to wipe this off. Yep. The percentage of data that lies between lies in one standard deviation about the mean. Okay, as stated by the empirical rule. Okay, and this is how empirical rule are established. Okay? Hey, will you comment on the teaching survey that handwriting is terrible? Don't. Although I feel that my handwriting is terrible, but don't comment. All right? It is still recognizable. All right? Roll call time. Roll call time. I said I will double the roll call. Twice. The first time for the second hour. 1. Hey, what happened? Ha! 这嘛是什么情形？很想飙脏话。Forget about it. For the second time, try again. Okay, try again. Okay? What happened? 这嘛是什么情形啊？哈！ It is not local time, it is lunch time. All right? 嗨，很想飙脏话。Forget about it. It does not work. 哈！ Hey, I will try again for the one last time, okay? I cannot log it in. So, the system is down. So forget about it. Anyway, I do twice. I did it twice, right? Yep. Okay. So see you next week. Later.
Sir,
Yep.
teacher, we already gave our review to the teacher assistant. So will that be counted as a point?
What?
already give a review to the teacher assistant too, sir. Will that be a part of a point, sir?
Review what? Let me finish this.
Teachers, the TA has already gave us the assignment
For what?
for
What?
the TA already has put out the assignment before the
You
teacher.
did the teaching survey for the teaching assistant?
Yeah, yeah.
Not for me? Not yet?
No, it's for you, but the TA has put the assignment in her there. 哦，就是叫把这个教学图片当做一个功课，
Uh-huh.
对，然后让我们上传找标。
But you have to do mine too, right?
Yeah, but I'm asking about like if we did the teacher assistant part, would that be a part of our points too, sir? You understand? 对，
就是教学图片会什么？
成绩。
Yep. For extra bonus. If you did, you got extra bonus.
哦，
If you're not, you don't.
不是 midterm 来期末了。
Yep. Yep.
Teacher assistant punya itu kita dikasih nilai buat lesson juga. Makanya gitu ya.
Yeah. What? You were not here, right?
Yes, I was
But I can only give you one because you didn't you did not raise your hand when I asked.
yeah, the second one. I didn't did the second one. I raised my hand for the
Inti
second
aja.
one.
Tapi yang kedua dapat gimana?
The system is down. No. No, not for no makeup because it's for addition, not for deduction. 有加分没扣分。I don't know. You can only I can only do the second for you. No, oh, okay, working. Second hour. Me? Oh, this one. Name? Cai Sanling. And you?
林玉轩上面。
Seat number?
呃，
What is your name?
林玉轩。
Seat number? It's down again. Hey, I cannot save because you don't. I forgot your name. I forgot. No, I haven't. I cannot save it because the system is down. Oh. Uh, you see the record? And what about yours? Lin Yuxuan, Cai Sanling. Oh, it's already kept. Okay. I know. I will delete it. 7。你们等一下要上课吗？哦，那我赶快收一收。